My name is Carson Neely.
And my name is Nick Vagnazzi.
And this is our demonstration of the solar system.
We purchased our model sun, which is a fake pumpkin of 50 centimeters in diameter at Walmart. This is the model clay we used for the project, and then we painted our model planets and used toothpicks to hold them during filming.
Now we begin our journey to the closest planet to the Sun in our solar system, Mercury. Its true size is 4,879 kilometers in diameter and over 57 million kilometers from the Sun. However, in our model, it's only 0.175 centimeters in diameter and just over 65 feet away from the Sun.
Enlarged for the purposes of this demonstration, this is a transit of Mercury. It is one of two planets that has transits, which occur when a planet passes directly between the Sun and Earth in orbit. From Earth, planets in transit can be seen as a black dot moving across the face of the Sun. This happens about 13 to 14 times per century for Mercury, with the last occurring on May 9th, 2016.
Next up is Earth's sister planet, Venus, which is over 12,000 kilometers in diameter and over 108 million kilometers away from the Sun. In our model, it is 0.435 centimeters in diameter and 38.87 meters, or over 127 feet from the Sun.
Also enlarged for the demonstration, Venus is the other planet that has transits, but these transits are much rarer, as they occur in a pattern that generally repeats every 243 years, with pairs of transits 8 years apart, separated by long gaps of 125.5 years and 105.5 years.
Now we move to the third planet, our home Earth, almost 13,000 kilometers in diameter, with its average distance from the Sun almost 150 million. It is 0.458 centimeters in diameter and 53.74 meters, or just over 175 feet away in our model. But what makes Earth even more significant is the Moon, its only natural satellite. The Moon is more than half the size of Mercury, orbits Earth from over 384,000 kilometers away, and is in sync and rotation with Earth, meaning it is always showing the same face. In our model, the Moon orbits Earth from less than half a foot away.
Up next is the phases of the Moon: waxing crescent, first quarter moon, waxing gibbous, full moon, waning gibbous, last quarter, and finally the waning crescent.
The Moon is also known for its solar and lunar eclipses. Solar eclipses occur like transits when the Moon passes directly between the Sun and the Earth. However, the difference is that a solar eclipse, the Moon partially or even fully blocks the Sun, making it look like one giant black ball in the sky.
Lunar eclipses, on the other hand, occur when the Moon is aligned exactly with and passes directly behind Earth and the Sun. These can only happen the night of a full moon. Now I'm in Earth's orbit, and here's what some near-Earth asteroids may look like.
Moving on to the fourth planet, Mars, it is about half the size of Earth, at over 6,700 kilometers in diameter, but it is over 227 million kilometers from the Sun. In our model, Mars is 0.244 centimeters in diameter and 81.87 meters, or just over 268 feet from the Sun. Now let's begin our journey to Jupiter, but we can't forget the asteroid belt.
Here I'm standing in the asteroid belt between Mars and Jupiter. This is what some of them may look like. Making our way to Jupiter, it is the largest planet in our solar system. Over 139,000 kilometers in diameter and over 778 million kilometers from the Sun. In our model, it is 5.02 centimeters in diameter and 279.69 meters, or over 917 feet from the Sun. It has 4 main satellites discovered by the famous Galileo orbiting it, named Io, Europa, Ganymede, and Callisto.
Io is the innermost of the Jupiter-Galilean satellites, which on this scale has a size of 0.13 centimeters in diameter and orbits at 0.15 meters, or about half a foot from Jupiter. Io takes about 42.5 hours to complete one full orbit around Jupiter.
The second innermost satellite is Europa, which is the smallest of the 4. In this model, it has a size of 0.11 centimeters in diameter and is 0.23 meters, or about 3/4 of a foot from Jupiter. Its orbital resonance is 2 to 1 compared to Io, meaning it takes twice as long for Europa to complete one full orbit around Jupiter.
The third Galilean satellite is Ganymede, which is the largest of the four, and the largest satellite in the solar system at over 5,200 kilometers diameter, making it larger than Mercury. For the demonstration, it has a size of 0.19 centimeters in diameter and orbits Jupiter at 0.38 meters, or about 1.25 feet away. Its resonance is 4-to-1 compared to Io, and it is the only satellite with a magnetosphere.
The fourth and final Galilean satellite is Callisto. It is the second largest of the four and the third largest in the entire solar system. For the model, it is about 0.17 centimeters in diameter and orbits Jupiter at 0.68 meters away, or about 2.5 feet. Unlike the other inner satellites, it does not form part of the orbital resonance that affects the three moons that are closer to Jupiter. This is Jupiter's Trojan asteroid belt. It is a large group of asteroids that share the orbit of Jupiter around the Sun. Each Trojan is located around one of Jupiter's two stable Lagrangian points, which is where I'm standing in both demonstrations.
Before we jump to the next planet, we wanted to inform our audience that due to the limits of the area we were using to film this project, we decided to take a different approach in showing you just how incredibly enormous our solar system truly is. We hope you enjoy watching the rest of it.
We now move on to the sixth planet, Saturn, which is the second largest planet in the solar system at over 116,000 kilometers in diameter and almost 1.5 billion kilometers away from the Sun. In our model, Saturn is 4.185 centimeters in diameter and 514.76 meters, or over 1,600 feet from the Sun.
Saturn is most famous for the rings that surround it, which are the largest and most prominent in the solar system. There are 7 total, however, with 5 main rings and many divisions between them. There are billions of particles in the entire system, with sizes ranging from dust-sized icy grains to a few particles as large as mountains. With a thickness of about 1 kilometer, they span up to 282,000 kilometers. The rings are labeled in the order in which they are discovered and not by proximity to Saturn. The order of these rings, starting with the blue, is D, C, B, A, and F, with the famous Cassini division between B and A, and the Roche division between A and F, both displayed in white.
Saturn also has 50 plus known satellites, but the first 4 discovered are by far the most significant and the ones we use in this model. In order of proximity to Saturn, they are Dione, Rhea, Titan, and Iapetus. The most intriguing is Titan, its largest satellite and the second largest in the entire solar system. In our model, it is 0.18 centimeters in diameter, with the other 3 all much smaller, and it is the only moon in the solar system with clouds and a dense planet-like atmosphere. According to NASA, Titan is one of the most Earth-like worlds we have found to date.
Moving on to the 7th planet, Uranus, over 50,000 kilometers in diameter and almost 3 billion kilometers away from the Sun. It is 1.822 centimeters in diameter and 1,033.48 meters, or almost 3,400 feet away in our model. It is the third largest planet in the solar system, and it is known as the ice giant, 80% of which is composed of hot, dense, icy materials. Uranus is known for its unique obliquity of 98 degrees, because not only does it have retrograde motion, but unlike any other planets, it's practically rotating sideways.
Neptune is the 8th and final planet we make our way to. Its actual size is just a bit smaller than Uranus at a little under 49,000 kilometers in diameter, but it is much further from the Sun at 4.5 billion kilometers. In our model, Neptune is 1.769 centimeters in diameter and a little over a mile away from our starting point. Also an ice giant, it is known for its supersonic winds and takes an incredible 165 years to orbit the Sun just once. Neptune's obliquity is 30 degrees, which is just 7 degrees more than Earth's.
The next step in our journey, formerly known as the 9th planet in our solar system. However, Pluto was demoted from the planet status in 2006 and it is now considered a dwarf planet. It is only about 2,400 kilometers in diameter, but it is almost 6 billion kilometers from the Sun. In this model, it is tiny, 0.09 centimeters, and 2,110.07 meters, or about 1.3 miles.
No, you're good. Charon, which used to be known as one of its moons, is about half the diameter of Pluto and was the solar system's largest moon relative to its planet. Now, Pluto-Charon is our solar system's only known double planetary system. These two icy worlds are in mutual orbit, meaning they spin around a common center of gravity like a pair of figure skaters clenching hands. Scientists believe they were shaped by a cosmic collision billions of years ago, much like Earth and the Moon. The same surfaces of Charon and Pluto always face each other, which is a phenomenon called mutual tidal locking. Finally, we end with an extrasolar planetary system, which is discovered when a star has a planet orbiting it. In our model is the star 51 Pegasi, orbited by its exoplanet 51 Pegasi b, also known as Dimidium, located at 50.9 light-years away from Earth in the constellation of Pegasus and just outside the constellation's Great Square. 51 Pegasi is 7.8 centimeters in diameter for this model, and its exoplanet is about half the size of Jupiter and orbits at 2.5 meters from the star. 51 Pegasi b takes about 4 days to orbit 51 Pegasi, and it was the first main sequence star found to have an exoplanet, with its discovery in 1995.